Assalamu alaikum. Roll number 191016. This was the task 1 of lab number 5, timers and counters. In this, we have to display the value of overflow and TC and T on LCD. And first of all, in ATMEGA Studios, we have written a code, and I am showing you this header file. Inside header file, we can see we have defined LCD 328p and all this, and then we have included our header files for delay, interrupt, standard library, and avr io.h. Even if we do not use this library, it is okay. And then we have defined control bus to our port P. The control bus is basically, it sends control signals to the among the other components, and data bus sends and receives data to them. Basically, these are the control pins of our LCD, and these are our data pins of our LCD. And the data bus and the data pins will be shown of the port C, and the control pins will be shown of port B. Here we can see that these are the pins of our LCD, RS, enable, and these are shown to us at port B4 and port B5. And then we have defined the pins of LCD, the data pins, as port C0, port C1, port C2 and port C3. The device that we are using in this task is not ATMEGA 2560, but rather it is Arduino Uno 328p. So we have made functions for the display of our LCD. The first function here is void LCD command write, and its data return type is character A. So if A and 0x80, these are basically the control or data pins of the of the LCD. So if A and 0x80, if we do AND operation between these two, then data bus that will work as, it will be data bus OR is equal to D7 will be shifted left with 1 bit, else data bus AND is equal to will not be equal to this will not we will negate this operation, and then if A and 0x40, then D6 will be shifted towards left with 1 bit, else we will do a NOT operation on this, otherwise it will not work. Nothing will be this D6 will be remain unshifted. And if A and 0x20 data bus OR is equal to D5 will be shifted towards left with 1 bit, else negation of this statement. And if lastly, if A and 0x10 data bus OR is equal to D4 will be shifted left towards 1 bit. Control bus, the control pins AND is equal to not RS will not be equal to RS will not shift to 1, and enable will not shift to 1, and control bus OR is equal to, that means enable will shift towards 1 bit left side. Then we have used a delay here of 20 millisecond. Then control pin, that control bus should be equal and equal to not enable left shift of 1 bit, and then we have used another delay. Basically, these control pins are controlled in a way that they do not be displayed so fast and with a, you can say, in an organized manner. Otherwise the data we cannot understand the data that is being displayed on our LCD. And then if these are our data pins, if A and 0x08 data bus OR is equal to D7 will be shifted left with 1 bit, otherwise else the data bus will not be shifted. Similarly, we will do an operation between A and 0x04, A and 0x02, A and 0x01 for data bus, that D6 will be shifted left with 1 bit, D5 and D4 similarly. And similarly here we can again control our pins through control pins, and then we used a delay and the same condition that we used here, again a delay. And then in wide LCD data write, we its return type of this character is character, and the data type of the return type of our function is void, that it will return nothing, empty. And basically in our LCD data write, we have to write the data in the form of string, and furtherly we can send data towards these pins, these data pins, and we can control our LCD through control pins here, same as we did in our LCD command write. Then in LCD init, we will set the control bus direction at RS will be shifted towards left with 1 bit, and I enable will be shifted towards left with 1 bit, and OR operation will be used. And then data bus direction will be set for all the data bins D7, D6, D5 and D4 that will be shifted left with 1 bit. And then we used the above then we used to call the function that we have written above, LCD command write for 0x01, 0x02, 0x01 for clear display, 0x02 for back to home, 0x28 for 4-bit 2 line 5 cross 7 pixel, LCD command write 0x06 for entry mode or cursor increments by cursor shift, LCD command write 0x0C display on cursor off, LCD command write 0x80 force cursor to begin at the line 1. Then at display we have used the above function LCD data write 2, and its return data type here is constant character *p. We have used a pointer here, so by it is called the LCD data write here will be called by reference, and the data and the character that we will use will be constant. That means it will not change when we will display our data. Then we will set the cursor first for before displaying it on our LCD, that it will begin on our first line. The first we have used here a switch case, and inside these are 3 cases: case 0, case 1, case 2. In case 0 we have called LCD command write function that it will force the displaying data on line 1. Then at 0x C0 it will display our data, and at 0x94 it will again set its cursor, and at case 3 again it will write our data. And then we have used a for loop that I should be equal to 0, its initialization I should be equal to 0, and the condition is I should be less than a, this int a, otherwise the for loop will not run. And then we have inside this for loop we have called a function LCD command write 0x14. In void LCD clear, we have to clear whatever the display has been shown first. It will clear our display, and then it will again move the cursor at home position. And these two functions are used to shift the LCD towards right, the display towards right, or the cursor towards right, and shift entire display right, and here it will be shift entire display left. So that was our header file. Now towards our main. First we have used LCD init, in which we have written all the LCD command write functions for different operations. We have used a header file in main function, otherwise this program will not run. We have used a while loop in which we have set the TCCR0A value of timer counter control register. Basically this program is used to count the overflow for that of the timer with prescaler 0. So TCCR0A here will be 0x0a, 0x00, TCCR0B, the timer control register 0B will be 0x01. This is for normal mode operation, and TCNT value is 0x00 because there is no prescaler. And then we have used a nested while loop inside that, in which timer interrupt register followed register is 0, and it is operation between TOV and TIFR, and TIFR 0 and 1, TOV 0, that is shifted towards left, and these two will perform an AND operation, and this will be equal to 0. And then after this operation, this timer counter operation will be performed. Then this is basically showing our timer overflow for our program. And then TCC after this operation while loop is being performed, then the TCCR0B will be cleared. That means it will be written as 0, and TIFRs it will be equal to this, that the timer overflow register will be shifted towards left with 1 bit. Then we have used a delay of 500 millisecond, and first we have used an unsigned character C that was equal to 0, and C will be equal to C plus TCNT 0. That means when a timer overflow function, if the value of our bits is being overflowed, the TCNT will be added inside the C and will be stored inside C. That means C is equal to 0 plus how many times it have overflowed here. Then we have called a function of LCD display overflow, and we have written the data of C. That means it will show our data of overflow. And we have used a delay, and then we have cleared our LCD. Now towards our Proteus. I've already debugged the program, so I'm directly going towards the Proteus, and we will start here. Here we can see overflow. First it is written, its value is 2, then it is 4, and finally it is 6, and it will carry on until the function or some other instruction has been given to our program. So that was all, and thanks for watching. And the hardware video will be shown next. Assalamu alaikum. Roll number 191016, task number 2 of the timers and counters, in which we have to make a digital clock. So first of all, here is our header file of LCD, in which we have defined LCD, and we have included headers and interrupt.h, and we have defined data as the port B, and RS, RW, and enable pin as 37, 36, 35. Then we have used a function of LCD command. I have discussed that in previous videos, so you can watch that there, its function. Similarly, all the other functions of like LCD data, LCD string, and LCD int, and all these. Now we will carry our task towards main, and here in this we have included some header files, and we have included the header file of lcd.h and some libraries that are used inside these tasks. So first of all, we have initialized our unsigned integer as of or as 0, minute, second, all 0, and check as 0. Then we have used a timer1 int function to initialize timer1, in which we have used CTC mode, operation mode of timer 1, and no prescaler. Then we have used it, then we have initialized the timer 1 interrupt, and then the timer 1 interrupt subroutine to control the variables of the clock. And here is our main code that was for the digital clock. If second is greater than 59, then second is 0 and minute is incremented. Similarly, if minute is greater than 59, then minute should be equal minute will be equal to 0 and r will be uh, incremented, and if r is equal to 20, r will be 0. Then character key scan, this is a function for uh, that if to configure the first 4 pins of port A as input and fifth pin as output, then we have to check continuously for the pressed key, and then we have to activate then we have activated the pull up for first 4 pins, and then we have scanned the first key, and as long as the key is pressed, the while loop will not terminate and it will return 1 if key 1 is pressed. Similarly for second key, third key, and fourth key. Then we have set our clock, and inside our clock we have initialized an unsigned character k is equal to 0, and then we have then we have used the LCD command function from the LCD header, and we have to remember the cursor is in auto decrement mode, so jumped as to jump to the end position, and then LCD data commands are used to display the time as 000000 on LCD. Then we used a while function in which k is equal to key scan, the above function we used, and if k is equal to 1, then second is incremented and all. If k is equal to 2, then minute will be incremented, and all these conditions for 3 is equal to r and 4 will be for break function. Then inside LCD clock, this function is used to display number, time in hour, minute, and second on LCD. Then in the main function we have set the direction of port B as 0xff. Then we have used the function LCD int to initialize the LCD. We have used a delay LCD command to clear LCD command 0x04 to auto shift the cursor on left side, and then 1 millisecond delay clock set function is used to set the clock timer 1 interrupt to initialize the timer 1 interrupt, initialize timer 1, and OCR1A should be equal to 0x03E8. If this is the calculated value for 1 millisecond starts the timer. Then we have used a while function in which we have used the function of LCD command 0x8b address to display second. Then we have used LCD command to address to display minute and display hour. So that was our LCD code in ATMEGA. Now we will carry out our procedure towards Proteus. I have already debugged the program and set the hex file inside the Arduino Mega. So let's see when we play the button. Here we can see the time is equal to 12, 0 and 2. So that was our digital clock on Arduino Mega. This was our task.